Dear learners, welcome to the NIOS. Today, we will be dealing with the fourth part of the properties of fluid. And today we are going for the Pascal's law, one of the most important law when we deal with the fluids. Here, we will be able to understand that what actually Pascal law states and what are the different applications that we are using in our day-to-day life. Through this diagram, you can see that on one side of the platform, a man is standing and on the other side, the car is placed. But both are connected by the fluid. Obvious, the mass of the man is very low comparative to that of the car. Then how does he able to lift a car with very ease? How does it work? Today we are going to learn this concept. Here we analyze the smaller force is exerted on one side and on the other side the area and the force is large. It is implied by using a Pascal's law. What does it state? It states that the pressure is applied at any part of an enclosed liquid. It is transmitted undiminished to every point of the liquid as well as to the walls of the container. Means there will be no loss of pressure anywhere inside the container. Now look at the smaller sides. At the smaller side, we are having a pressure given by F1 by A1, the ratio of both the quantity, which must be equal to the pressure on the larger side, which is given by F2 A2. We already know that the transfer of pressure is undiminished. That's why both the pressure are equal to each other. And it is then very easy to lift any heavy object by using a very small amount of force on one side. Now, according to Pascal, we had already explained. Now it is denoted mathematically. At the last of the equation, F2. F2 was the amount of force which was exerted on the larger side of the area. Here, the pressure is exerted in terms of the smaller side. So the pressure is given by F1 A1. And for the larger side is it given by A2. Therefore, when both the quantities are equal and by cross multiplication, the two equations, we got this result. And this is the actual mathematical concept behind the Pascal's law. This law is also known as the law of transmission of liquid pressure. Now, turning towards the application, the basic uses are the hydraulic press, the hydraulic balance, and the hydraulic jack. The very first application that we had already shown you, hydraulic jack. Here, we again gave the demonstration in a very detailed that how do we get an amount of small force on one side of the tunnel and the amount of larger force on the other side of the platform, which is connected through the liquid. And we are easily able to lift the car over to placed which is over to the platform. So the force in small cylinder must be exerted over a much larger distance. A small force exerted over large distance is traded for a large force over a small distance. This is somewhat an inverse case. So a small force will turn out to be a larger force on the other side. Then the hydraulic brakes. The hydraulic brake is used basically in the vehicle or the four-wheelers, where the pressure applied gets transmitted through the brake oil to the piston of the slave cylinders, which in turn pushes the brake shoe against the brake drum in the four wheels simultaneously. Then only the wheel stops rotating and the vehicle comes to stop. Here is a demonstration. The foot shows the brake pedal, which is connected to the master cylinder where the fluid or the brake oil is inserted, which is interconnected to that fluid, the caliper and the disc. When this caliper or a disc gets open up, it attaches to the rotation of the wheel and it gets stopped. So till now we had learned that what is actually a Pascal law, what are the applications of Pascal law. Thank you.